Hello, this is an explanation of questions 10, 11, and 12 from the week areas worksheet. I've had some people questioning probably most specifically what's going on with number 11 and why I chose to use the IVT as opposed to the MVT, but I'll run through all of these. So in number 10, I'm asked, is there a value C on the interval from 0 to 9? Where f of c equals 6. So I'm going to look at the f of x values, and I'm looking to see if I am guaranteed that I'm going to bypass the value of 6. So I look at it on the different subintervals, so negative 10 to negative 2. Nope. 2 to 4. Nope. 4 to 3. Nope. I hit the 6 in between the 3 and the 7. So this is the area right in here, where I'm guaranteed to have an f value of 6. So I just, that's IVT. So I just lay out the conditions necessary. I'm told that f is differentiable. Therefore, I can say that f is also continuous, and I'm going to use the IVT. What I need to do is position this value of 6 in between these two values. And you could call them 7 and 3 if you want to. So you could say 3 is less than 6 is less than 7. So just position that 6 in between the 3 and the 7, or you can use function notation like I did here. And so if 6 is between these two values, I know by the IVT there's a value C on the interval from 6 to 8, on this x interval 6 to 8, where f of c is going to equal 6. It's just a classic IVT type problem. And when I got to number 11, this says, is there a value C on the interval from 0 to 9 where f prime of c equals 3? So what I did on this one first is I looked at the f prime values, and I just looked to see if I was guaranteed to bypass 3. So I'm using IVT on f prime. And I can see that right in here from 2 to 4, f prime is going to bypass the 3. So I used IVT on this one just because I could. So I just did IVT just like I did number 10. I did it with number 11. So I know that the 3 lies in between the 2 and the 4. So there will be a C value between 0 and 2 that I'm going to achieve that value of 3. I don't know exactly what that x value is going to be, but I can guarantee it's some x between 0 and 2. So I just lay out the IVT like I did in number 10. So since f prime is differentiable, it is also continuous because continuity is what's required for that IVT. And then I just did the same thing. I positioned the 3 in between the f prime of 0. So f prime of 0 between the 2 and the 4. And again, you could use those actual values if you wanted to. So it's perfectly okay here to say 2 is less than 3 is less than 4. In other words, 3 lies between the 2 and the 4. And then on number 12, if I try to do on number 12 what I did in number 11, which is now I want to know where f prime of c equals 1, I look at all these f prime values, and nowhere am I guaranteed to bypass a 1. And that's using the IVT. So IVT is not working on number 12. I chose it on number 11 because it worked on number 11, and it's a little bit simpler to use than the MVT instead of looking at a bunch of different intervals. So what worked in number 11 doesn't work in number 12 because my f prime values never bypass 1. So what that tells me is I'm going to have to use something other than IVT, and that's where MVT comes in. So what I do for MVT is I look in this F row, and I see if I can find an average rate of change that equals 1. And then by MVT, I'd be guaranteed an instantaneous rate of change that also equaled 1. So I just go through different intervals, and I just do in my head a quick average rate of change. So this would be 8 divided by 2. So this would have a 4, but I'm looking for a 1. This would be 6 divided by 3, so my average rate of change here is at 2. This would be a negative 1 over 1. That would be a negative 1 average rate of change, but I'm looking for a 1. So I just go through and I kind of hit it right here. And it takes sometimes a little bit of looking and a little bit of calculating in order to identify the interval, but I see it right here because when I do 8 minus 7 divided by 9 minus 8, I get 1 over 1. So I first find my interval right here. So this is my interval right here. And then I just lay out my MBT. This requires a differentiable and a continuous function, so I say that I know function f is both of those things. Therefore, I can use my MBT. And what the MBT says is if you can find a place where the average rate of change equals 1, and I have found it right here. So f of 9 minus f of 8 over 9 minus 8 equals 1. I am guaranteed to have an instantaneous rate of change. That's this f prime of c that also equals 1. So I used MBT on that one. So I guess the bottom line is if you can use IVT, even with f prime values, then do it. And if you can't, if you don't see those f prime values equaling, for instance, 1, then try to use the MBT. So if you can use the IVT, so just look and see if IVT applies, and if it does, then use it, and if not, then turn to MVT.